Okay, everybody, we got one last question that we're going to deal with. And then the last question you're going to do on your own. It says a recent study published in the Journal of Pediatrics examined research on emergency visits by randomly selected patients suffering from abdominal pain. The following data was collected on the ethnicity of each patient and whether or not they were given medication for pain relief. So before we go on, just want to take a little side note here. I know a lot of you are in HOSA or in the Health Academy that you've probably noticed that we've done a ton of different problems dealing with the medical field. And the reason is because medical field in particular uses stats a ton. So if that is kind of your projected career path, just know that there's a lot of useful stuff that you're going to be able to learn. You're learning now that's going to help you later on in college and when you get your job after college. So just keep that in mind. If you're able to understand this is going to just give you more opinions as you're assigning medications, assigning the best possible treatments to your patients. If you understand studies, and it's just going to help you out in your medical profession as well as pretty much any other field that you're going into if you are not a health student. All right, that aside, let's dig into part A here. So it says, suppose one of the patients were selected at random. What's the probability that she was provided with pain medication given that she was Hispanic? So this problem is not a test problem, a significance test problem. It is just a regular, simple probability two-way table problem. And you're going to see this you might see this on the AP test where they throw an old probability question with one of these chi-square tests because it's dealing with a two-way table, which we can also do probability questions with. So just like we reviewed a couple classes ago, we want to look to see if there's any restrictions. So we have a restriction where it says given that she was Hispanic. So we're just going to look at the total for Hispanic, which is 433. Then the number that's got medication was 91, so we divide those and we get 18.84%. So yeah, that was part A, pretty straightforward. Now the rest of this is our significance test. Erase all this so we can start nice and fresh on this problem. All right, so it's asking us what type of tests we are trying to do for this problem. All right, so you can see, like I just said, we have a two-way table. So we can cross off goodness of fit test. Second, for which one of the chi-square tests we have remaining it is, we have to think about, are we dealing with one sample or multiple samples? And it just says they had visits by randomly selected pediatric patients suffering from abdominal pain. Okay, so it didn't say anything about multiple samples, so it's just one sample. All right, so if it was just one sample, it's going to be a test for chi-square test for independence or association. I'm going to call it now for the rest of this video test for association, but no, it's the same thing as test for independence. So we're going to write that down first on our significance test, so chi-square test for independence or association. Now we need to have our hypotheses. So our hypotheses, just like the last one, we're going to write these out in words. So our null hypothesis is that there is an association between a patient's race and the probability that they will get a medication. So anytime we're doing a test for association, your null hypothesis is going to be there's not association between variable A and variable B, and then you just plug in the context of those variables to get your answer. For your alternative hypothesis, there is an association between a patient's race and the probability that they will get medication. So it's the opposite of that. So null hypothesis is a statement of no difference. An alternative hypothesis is going to be the opposite of that. So there is an association. All right. So null for any situation for independence association test is there's not an association, and the alternative is going to be there is an association, which is the reason why I like to call it a test for association, because it helps kind of remember how to write your alternative hypotheses. So then we have our conditions. They're the same conditions as our test for homogeneity. So they're randomly selected. Our 10% condition is met. And then our expected values need to be greater than 5, which we aren't given our expected values, and we'll show you how to get those because I forgot to do that in the previous video, so I want to make sure we take time to talk about that in a second. But we're going to skip that part for right now. So the next thing we want to do is calculate our use our calculator to calculate our p-value, our chi-square statistic, degrees of freedom. Then it's also going to give us our expected values. So that's why we're skipping that part for right now. So just like we learned in the last couple of videos, I'll scroll back up here so we can look at the directions. For your calculator, you're going to go to your matrix screen, which is seconds, the x to -1 button, the inverse button on your calculator. Say matrix there in blue. So you go to the matrix screen. Then you're going to go over to edit. In matrix A, you're going to put your observed values. So we're going to put all these values right here into matrix A. All those values into matrix A. So you put your observed values into matrix A. That's all you have to do. Then you're going to go to Stat, go over to the right to the menu that says Test, and we're going to select the chi-squared test. All right, make sure you don't do the chi-squared goodness of fit test. For this one, this menu option right here, this is the same as the homogeneity and independence test. So it's exactly the same calculator commands that we did for the last one, even though this is an independence and the last one was homogeneity. Now, if we move down, once you did in your calculator, you're going to come up with your chi-square test value, which is 39.5. Your p-value is going to be 0.00000013. It's a very low probability, and degrees of freedom are 3. The ways we get degrees of freedom is you take your number of rows minus 1 times the number of columns minus 1. So we have 4 columns minus 1, which is 3, times 2 columns minus 1, which is 1. So 3 times 1 is 3. That's how we get our degrees of freedom. All right. So then we move on to getting our expected values. Now this is something I forgot to tell you in the last video, and I'm pretty sure I didn't have it in the YouTube video, so make sure you pay close attention to this. So you're going to need to write down your expected values as part of your work, and it's really a complicated process of getting your expected values by hand. So you can just use the calculator to do it. And as long as you use the calculator command, it's automatically going to store those values into matrix B. So what you want to do is you go to your calculator command, the matrix screen, then go over to edit matrix B this time. In your calculator, put all of the expected values. They calculated it for you and put it into matrix B. So the only thing you have to do is then copy down those values into a little table on your paper, label UV expected values, and you're good to go. As you can see, you don't have to make it look super pretty. When I'm doing these tests, I'm trying to fit in like the 12-minute period that you get on the AP test. So don't spend tons of time making sure it looks perfect. Just make sure you can clear, and if you make a mistake, just cross it off or erase it. Like you see I did here a couple times. I didn't even take time to erase it. I just crossed it off so I could keep on going and not waste any time. But we have all of our expected values now, and we can see now that all of our expected values are greater than 5. So that helps us check off that last condition, and that's why I'm kind of waiting to do that last condition till the end there. We can also use the expected values to kind of further analyze our data. So even though we have a low p-value, we can break it down, and we can see that the observed values for the white population were higher for being given medication, and all the other races were not. So that's the main reason that our p-value is low. Now, we don't know exactly why. There's dozens of reasons that could be contributing to that, but we know there is an association. And if we wanted to go further in depth why that is, that'd be like another study that we could do. But our interpretation is just dealing with, is there association or not? This is a test of association. So we say since our p-value of 0.00000013 is less than our significance level of 0.05, we have statistically significant evidence to reject the null hypothesis, which means that we have evidence there is an association between a patient's race and their probability of given medication. So that's how we analyze our data there. Okay, analyze our whole test. Again, just like all these significant tests, I know there's stuff that's slightly different, but if you just keep that format the same, hypothesis, conditions, calculate the p-value, interpretation, and it's going to be a lot easier as we're going between all these different types of tests, which we're going to spend a lot of time doing as we're spending the next 3 weeks reviewing for the AP test. Oh, one last thing. Just to make sure that you are listening to all of these videos. And if you've listened to this video straight through, great job. If you are listening right now and you email me the name of your favorite color by the end of class, I will give you 5 extra credit points on your 2 lowest summatives as a reward for making sure that you are watching these videos during class and watching them all the way through. So one last time, if you just made it through this video and when watching it in class, if you email me your favorite color by the end of class, you will get 5 points extra credit on your lowest 2 summative grades. So a little incentive to making sure you're watching all these videos in class straight through.